pollution is a huge problem around the world, and we know it impacts our health.
And that is a look at New Delhi. Air pollution is putting the health of millions of people at risk there. Pollution levels are 10 times the safe limit.
Smoke from forest fires drifting over communities, smog so thick it obscures city streets. It can sometimes be easy to see air pollution, but understanding the risks involves more than just looking around. Nearly 2,000 people die each year in Canada from diseases related to air pollution.
I think at this point we all know that air pollution is bad for us, but something I don't think many people are aware of is how you actually study air pollution. So that's why in today's video, I'm going to show how I studied air pollution in Grenada, West Indies. If you're going to conduct any research, it's fundamental to know what your research questions are. What exactly is the point of this research? Previous to my thesis project, there have been no systematic outdoor air pollution monitoring campaigns conducted on the island of Grenada. Therefore, my research team were interested in answering the following questions. 1. How is air quality in Grenada? 2. How do air pollution concentrations fluctuate across the island? 3. How do these concentrations change on different timescales? 4. What impacts air quality on the island the most? And 5. How impactful is Saharan desert dust? Since we had our air pollution monitors running during the unexpected onset of the COVID-19 pandemic, we were also interested in answering the following. How did COVID-19 restrictions affect air quality in Grenada in 2020? Having research questions leads to establishing research objectives for your study, targets to be aimed at achieving. The two objectives that I had for my project were 1. To examine changes in outdoor concentrations of PM2.5 air pollution at different timescales in Grenada between January 6th and December 31st, 2020, and to assess how these concentrations changed during Saharan desert dust events. And second, to assess how COVID-19 restrictions impacted outdoor concentrations of PM2.5 in Grenada in 2020. Our choice of air pollutant to examine for this study was largely motivated by the known negative impact that PM2.5, or fine particulate matter, has on human health upon exposure. Before you set out to achieve your research objectives, you first have to formulate your study design. How exactly will you conduct your research? What is your plan? For my study design, I sought to A. Perform an air monitoring study where I examined outdoor concentrations of PM2.5 on varying spatial and temporal scales using low-cost PurpleAir monitors installed at 5 different locations across Grenada and its neighboring islands of Caracau between January 6th and December 31st, 2020. B. To collect daily meteorological data and examine their relationships with ambient PM2.5 concentrations. C. To identify days that were impacted by Saharan desert dust in Grenada and to examine its relationship with ambient PM2.5. And D. To record all relevant COVID-19 restrictions that were implemented in Grenada and assess their relationships with ambient PM2.5. The approach that I took for the study design was quantitative rather than qualitative. As mentioned in this great article titled, What is a Research Design? Quantitative approach can involve measuring variables and describing their frequencies, averages, and correlations, which I did a lot of, and testing hypotheses about relationships between variables, which I also did. Now that I've gone over a brief version of my study design, let's take a look at what data I collected and where I collected it from. All of the outdoor PM2.5 data that was collected for this project was with the use of the PurpleAir PA2 SD monitors, and these were installed at 5 different locations for this project, 4 on the main island of Grenada and 1 on the neighboring island of Caracau. Now, each monitor location that we selected had 2 requirements. 1, it had to have access to a power supply, and 2, it had to have access to a Wi-Fi network. 4 of the 5 monitor locations were either on the roof of a house or on the upper wall on the outside of a house. And of these 4 locations, 3 were in sparsely populated areas with little nearby road traffic, and thus it was defined as rural. Meanwhile, 1 of the 4 was situated near Grenada's capital city, St. George's, and near a main road. Thus, it was defined as urban. And finally, our 5th monitor location was at ground level on the tarmac of Grenada's Maurice Bishop International Airport. Now, with that being said, let's dive into the nitty-gritty of the air quality monitors that I used, the PurpleAir PA2 SD monitors. These monitors measure particulate matter, relative humidity, and temperature, but how do they actually work? As you can see here, each of the monitors contains a pair of laser optical particle counter sensors. Each of these sensors produce measures of PM by drawing in samples of air past a laser beam and registering pulses for any particles in the air that reflect light onto a detection plate. The length of each pulse determines the size of the particle, and the number of pulses estimates the particle count. In general, PurpleAir monitor measurements have been shown to correlate reasonably well with measurements from higher quality monitoring devices. Now, as for the meteorological data, we received hourly measures of precipitation, wind speed, atmospheric pressure, temperature, visibility, and what was the other one? Relative humidity, all from Grenada's Meteorological Office at the Maurice Bishop International Airport. Due to the size of the island, there's little spatial variation in each of the 6 meteorological parameters. Thus, the data that I received from the Meteorological Office reasonably reflected the conditions at the 5 monitoring locations. From January 6th to December 31st, 2020, I identified whether Saharan dust days occurred in Grenada or did not. And to identify these Saharan dust days, I use a composite method, making use of multiple data sources. As naturally occurring and anthropogenic aerosols affect U.S. Navy operations in nearly all parts of the world, the U.S. Naval Research Laboratory developed an aerosol analysis and prediction system that forecasts the distribution of tropospheric aerosols globally. This aerosol forecast model produces images of dust surface concentration around the world, up to 6 days in advance, at 6-hour intervals. NAPS was also helpful for me in identifying Saharan dust days retrospectively, as archived forecast images are available to be viewed spanning back to March of the year 1998. What was also helpful for me in identifying these Saharan dust days in Grenada were the hourly visibility measures that I obtained from the Meteorological Office at the Maurice Bishop International Airport. MER2 is a NASA atmospheric reanalysis that assimilates space-based observations of aerosols via satellites and represents their interactions with other physical processes within Earth's climate system. MER2 produces many different products, but for my method of identifying Saharan dust days, I used it to obtain dust aerosol optical thickness maps. Aerosol optical thickness can be defined as how much of the aerosols in the entire column of the atmosphere prevent the transmission of light, either via absorption or scattering. From March 2020 onwards, the government of Grenada implemented a series of public health restrictions to reduce the spread of SARS-CoV-2. I first constructed these daily measures of curfews and social gathering limits that were implemented in Grenada using information published by the daily news outlets Now Grenada and Loop News Barbados. I also created daily measures of commercial airplane movements, so arrivals and departures, and boat/ship movements to try and capture the travel restrictions that were being implemented on the island of Grenada. Using the FlightStats online database, I was able to extract daily data on commercial airplane movements for Grenada's Maurice Bishop International Airport. In contrast, daily data on boat/ship movements in and out of Grenada's main ports were provided by the Marine Department of Grenada's port authorities. And finally, I constructed a binary yes or no variable to demonstrate when emergency powers/Public Health Act regulations were implemented on the island of Grenada. These regulatory actions signal the broad implementation of COVID-19 related public health measures. Here are the data sources that I used and the variables that I produced using these data.